and I still haven't got it all figured out. I assume you sent for me because somebody told you I was the best. Well, I'm only the best because I work with the best. If you don't trust the men you're working with, you're as good as dead.
Let's go to a really simple example. We're going to look at salary. Let's ignore years. That's actually in the data set that I'll show you later on. And gender, where we have females and males. The idea for using regression would be we would have female data, we would have male data, and we want to test whether this regression line, when we go through the average for the females, doesn't need to change to go through the average for the males. If it goes up, that indicates males are getting paid more, or if it goes down, that indicates males are getting paid less, or if the slope is flat, that indicates they're getting paid the same. So this feels very similar to the way we've done regression, except female and male are categorical. You can't do regression with categorical effects, but we could if it was numerical. We're going to steal an idea that you might have seen when we did proportion tests in the intro class. There, we changed these yes or no categories to 0 or 1, and that led us into the proportions test. Without doing all the math, here's the idea that we can see, does the slope change as it goes from 0 to 1? It doesn't actually matter what numbers we use here, but it's nice to use 0 and 1 because mathematically those are easy to multiply and add, so we pick up some perks there. There's a reason why I picked females to be 0. That's because alphabetically they come first, and that's the way R is programmed to handle this. So I can redo this column with 0s and 1s, and then I have numerical by numerical to do regression, and the slope, if it's significant, tells me that they are not being paid the same. Be warned, this trick works really well when there's 2 categories, yes and no, 0 and 1. There's a problem that happens if there's 3 categories, and we'll talk about that after we're done with this example. I want to play with the bank data. Here you can see the salary. Here's their gender. Here's the years they worked at the bank, which we're ignoring this column for right now because we're trying to keep it simple. So if I plot what the data looks like, it looks pretty similar to the picture I had on the board. Female to male, does it look like there's a difference in the salaries? I would say based on this picture, it looks like there is. But let's use regression to figure it out. So far in this case, it's very simple because we're only interested in one categorical effect. We don't have other numerical variables, which is what we want to get to at the end of this chapter. But this is all we're doing for right now. You may notice that the residual plot looks kind of funny because all our data is either female or male, so it's all shoved to one side or the other. But does it look like there's a general change as we go across? If there is, it's really subtle. Even the normality plot seems to be okay. And here there aren't any particular outliers. Look at our output, and here we see the gender effect right here. And you'll notice we only have male listed. Female doesn't need to be listed because this talks about if we change from female to male, is there a difference? And the small p-value here says, yes, there most certainly is. That tells us there is a difference in the means between these 2 genders. These numbers here have importance. Usually we don't talk about the intercept as really having importance because what we want to answer is whether males are getting paid differently than females. Can interpret this. This is the value that people are getting paid before we switch to being male. So this is the female salary. On average, females are getting paid about $54,000. Males are getting paid about $41,000 more than the females. So to figure out what the males are getting paid, we'd have to do a little math. This is about 95. Let me show you with this picture what I mean. Right here at 0, this is the y-intercept. And this is where that y-intercept of 54.732 goes. And the slope, which was 41, that is if we move 1 in the x direction, how much do we move in the y direction? So are males being paid more than females? In this example, yes, they're being paid $41,700 more. That's significant. This number right here at the top is about 96,000. That's what you get if you take the 54 plus the 41. But could that just be luck? Maybe your sample happened to be random where the women were only 54,000 on average and the men were 96,000 on average. Well, this p-value right here says no, it's not just luck. Something's going on and we want to investigate this. Now notice I could have done a t-test for that with the males and the females being separated. And if I do that, I get the mean of 96 for the males and 54 for the females. And are they different? Yes, it's the same p-value, it's the same test. But our goal now is going to be to investigate more. Can we include the years they have worked to tell exactly why these genders are being paid different amounts on average?